1969. The motorcycle world stood still. Four gleaming exhaust pipes emerged from an engine, unlike anything anyone had ever seen on a production motorcycle. This was the machine that would earn the title, the world's first superbike. This is the story of how Honda's CB750 completely revolutionized motorcycling and sent the entire industry into chaos. The late 1960s motorcycle scene was dominated by British twins. Triumph, BSA, and Norton ruled the roads with their 650cc parallel twin engines. These were considered the pinnacle of motorcycle performance, until Honda decided to change everything. Honda had already proven itself in the small bike market, but Soichiro Honda had bigger ambitions. The American market was demanding more power, more reliability, and more sophistication. Honda's response would shake the motorcycle industry to its core. What Honda unveiled next would make these British twins look like antiques overnight. But the story behind this revolutionary machine goes deeper than most people realize. To understand the CB750's impact, we need to go back to post-war Japan. Soichiro Honda started his company in 1948 with a simple goal: providing affordable transportation to a nation rebuilding itself. His first product wasn't even a complete motorcycle, but a simple motorized bicycle using surplus generator engines. By the mid-1950s, Honda had become Japan's leading motorcycle manufacturer. The small displacement bikes dominated the Japanese market through superior engineering and manufacturing processes. While European manufacturers still used traditional casting methods, Honda pioneered new aluminum die casting techniques that produced lighter, more precise components at a fraction of the cost. The Super Cub, introduced in 1958, showcased Honda's ability to mass-produce sophisticated motorcycles. Its pressed steel frame and horizontal engine layout were revolutionary for their time. The bike's reliability and ease of use made it popular worldwide, but Honda knew they needed something more to crack the premium motorcycle market. Honda's racing program became the testing ground for their most advanced technology. In 1959, they shocked the racing world by entering the Isle of Man TT. European manufacturers dismissed the Japanese company's efforts, considering their small displacement bikes toys compared to established racing machines. The team's entry into Grand Prix racing revolutionized motorcycle competition. Honda's RC series racing bikes featured technology that seemed impossible for the time. The RC161's four-cylinder 250cc engine could achieve 20,000 RPM, a figure that seemed almost mythical in 1961. Their racing success provided crucial insights into multi-cylinder engine design, high-speed reliability, and advanced metallurgy. These racing innovations directly shaped the CB750's development. The knowledge gained from building and racing multi-cylinder engines proved invaluable. The team learned crucial lessons about engine balance, cooling systems, and valve train design that would later be incorporated into the CB750. In America, the motorcycle market was undergoing significant changes. The post-war economic boom had created a new breed of motorcyclist. These riders weren't interested in basic transportation. They wanted machines that could deliver both performance and comfort. The British twins of the era, while powerful, had significant limitations that were becoming increasingly apparent. The technical limitations of British bikes deserve closer examination. The Triumph Bonneville, considered the benchmark of performance, used a 650cc parallel twin engine producing around 46 horsepower. Its antiquated pre-unit construction meant the engine and transmission were separate units, leading to alignment issues and oil leaks. The primitive electrical system supplied by Lucas Industries was so unreliable that riders often carried spare parts on long trips. BSA's offerings faced similar challenges. Their A65 Lightning shared many components with Triumph, as BSA owned Triumph at the time, and suffered from identical reliability problems. The bike's vertically split crankcase was prone to oil leaks, and its electrics were equally troublesome. Norton's Atlas, while renowned for its handling, vibrated so severely at high speeds that mirrors became useless and frames would crack under prolonged use. Want to learn more about legendary motorcycles? Hit subscribe. We're just getting started. The Japanese approach to motorcycle manufacturing represented a fundamental shift in thinking. While British bikes were essentially hand-built, with components often requiring adjustment during assembly, Honda designed their motorcycles for precise mass production. Every component was engineered to exacting tolerances, ensuring consistency across thousands of units. In 1968, Honda assembled a special development team for Project 300, led by engineer Yoshiro Harada. Their mission was clear: create a high-performance motorcycle that would revolutionize the industry. The requirements were demanding. The bike needed to exceed the performance of British twins while offering unprecedented reliability. It had to be sophisticated enough to impress experienced riders, yet accessible to newcomers. The development team made several groundbreaking decisions that would influence motorcycle design for decades. While British manufacturers were experimenting with three-cylinder engines like the BSA Rocket 3 and Triumph Trident, Honda went straight to 4 cylinders. This decision wasn't just about power, it was about smoothness, reliability, and the future of motorcycle design. The engine development process was methodical and innovative. The 736cc displacement was achieved through a bore and stroke of 61 by 63 millimeters, nearly square dimensions that allowed for high RPM operation without excessive piston speeds. The single overhead camshaft design was chosen for its optimal balance of performance and reliability, while also being easier to manufacture than a double overhead cam system. Honda's engineers broke new ground with their bearing design. Instead of using roller bearings, which were common in motorcycle engines of the era, they opted for plain bearings, a practice borrowed from automotive engineering. This decision improved reliability and reduced manufacturing costs, though many critics initially questioned its wisdom. The valve train represented a significant advance in motorcycle engine design. Honda's engineers created a robust system that wouldn't require adjustment for thousands of miles, unheard of at the time. The cam chain tensioner was automatically adjusted, eliminating another maintenance headache common to British bikes. The valve springs were designed to handle higher engine speeds while maintaining reliability, a direct result of Honda's racing experience. The decision to mount the engine transversely was another stroke of genius. This orientation improved cooling and allowed easier access for maintenance. It also created space for the sophisticated 4x4 exhaust system, which became a signature styling element. The exhaust design itself was a masterpiece of engineering, carefully tuned to enhance both performance and sound quality. The electrical system was a quantum leap forward in motorcycle design. Honda used a 280-watt alternator, massive for the time, ensuring stable power for the ignition and lighting systems. The electronic ignition system eliminated the need for regular point adjustments, while the starter motor was automotive-grade for reliability. The wiring harness was fully enclosed and protected from the elements, a stark contrast to the exposed wiring common on British bikes. The braking system represented perhaps the most significant innovation. While commonplace today, in 1969, motorcycle disc brakes were exotic racing technology. The CB750's disc brake offered superior stopping power and fade resistance compared to the drum brakes used by every other manufacturer. The single 296mm disc was clamped by a single piston caliper, providing consistent braking regardless of weather conditions or temperature. Frame design underwent extensive development. Using computer analysis, rare in 1969, Honda's engineers created a structure that balanced rigidity with appropriate flex. The frame geometry was conservative by British standards, but provided stable handling at high speeds, crucial for American highways. The swing arm was significantly longer than contemporary designs, improving stability and traction. The testing process was unprecedented in its scope. Test riders logged hundreds of thousands of miles in various conditions. The bike was tested in Death Valley heat and Alaska cold. High-speed stability was verified on Germany's autobahns, while low-speed handling was evaluated in congested Japanese cities. Durability testing included running engines at maximum power for extended periods, far beyond what any customer would attempt. When Honda unveiled the CB750 at the Tokyo Motor Show, the response was immediate and overwhelming. The combination of features seemed impossible. A 4-cylinder engine producing 67 horsepower, electric start, disc brake, 5-speed transmission, and reliability, all at a price point that undercut comparable British bikes. The technical specifications were revolutionary for a production motorcycle. The engine produced its peak power at 8,000 RPM, significantly higher than any British twin. More importantly, this power was delivered smoothly, without the vibration that plagued twin-cylinder designs. The bike could cruise at 80 miles per hour all day without strain, something few other motorcycles could manage. The manufacturing process itself set new standards for the motorcycle industry. Honda developed new techniques for mass-producing complex components with unprecedented precision. The engine cases were die-cast with tolerances that seemed impossible for the time. The crankshaft was forged from a single piece of steel and balanced to automotive standards. Even the paint process was revolutionary, using electrostatic coating for durability. American motorcyclists responded with overwhelming enthusiasm. The initial production run of 1,500 units per month proved woefully inadequate. Honda had to build an entirely new production facility to meet demand. By 1970, they were producing 3,000 units monthly and still couldn't keep up with orders. Waiting lists at dealerships stretched for months. The impact on motorcycle dealers was transformative. The CB750's reliability meant fewer warranty claims claims and happier customers. The profit margins were healthy, and the bike's reputation brought new customers into showrooms. Many dealers who had specialized in British bikes began shifting their focus to Honda, recognizing the changing tide in the industry. Racing success quickly followed the CB750's introduction. Dick Mann's victory at the 1970 Daytona 200 demonstrated the bike's potential on the track. The win was particularly significant because it came against purpose-built racing machines from established manufacturers. Modified CB750s began dominating production racing classes worldwide. The CB750's racing achievements continued throughout the early 1970s. The bike proved remarkably adaptable to different racing formats, from road racing to endurance events. Its robust engine could be tuned to produce significantly more power while maintaining reliability. Racing versions routinely achieved over 100 horsepower, an astonishing figure for the time. The impact on other manufacturers was immediate and profound. Kawasaki, which had been developing their own 750cc triple, scrapped the project and started over with a 4-cylinder design. This became the Z1, released in 1972 with even more power than the CB750. Suzuki and Yamaha followed with their own 4-cylinder designs, establishing the configuration as the new standard for high-performance motorcycles. In Europe, the effect was devastating. British manufacturers, already struggling with labor issues and outdated manufacturing processes, couldn't compete with Honda's technical sophistication and manufacturing efficiency. BSA ceased motorcycle production entirely. Norton tried to compete with their Commando, but couldn't match the CB750's reliability or performance. Triumph struggled on but would eventually face bankruptcy. The CB750's influence extended far beyond its contemporaries. It established the blueprint for the modern Superbike, a powerful multi-cylinder engine, substantial frame, disc brakes, and reliable electronics. This basic formula remains largely unchanged today, more than 50 years later. The manufacturing techniques Honda developed for the CB750 transformed motorcycle production worldwide. The level of precision and consistency achieved became the new industry standard. Other manufacturers had to modernize their production methods or risk becoming obsolete. The era of hand-built motorcycles was effectively over. The bike's success also transformed Honda as a company. It proved they could compete and win in any motorcycle market segment, from small commuter bikes to high-performance machines. This confidence led to further innovations and eventually expansion into automobile production. The CB750's success helped establish Japanese engineering excellence globally. Modern motorcycles owe much to the CB750's innovations. The transverse 4-cylinder engine layout remains standard for sport bikes. Overhead camshafts, disc brakes, and reliable electronics, all features pioneered or popularized by the CB750, are now universal. Even the basic architecture of modern motorcycle engines can be traced back to the CB750's design. Its reliability set new standards that all manufacturers had to meet. It showed that a high-performance motorcycle could be as dependable as a car, fundamentally changing consumer expectations. This shift forced the entire industry to improve quality control and engineering standards. The days of accepting regular maintenance and repairs as part of motorcycle ownership were over. The motorcycle industry would never be the same after the CB750. It marked the moment when Japanese engineering excellence became undeniable, and the future of motorcycling was forever altered. The revolution that began in 1969 continues to influence motorcycle design today. But there's another aspect to this story that few people know about, one that reveals just how close this revolutionary motorcycle came to never existing at all. That's a story for another time.